I'm actually very happy to be here to talk with you. Thanks for inviting me for this idea. And I think what I was excited about is this idea of a TED-like talk. So I'm going to tell you what we're doing experimentally with some of the work. But then I think the interesting part is, what does this mean as we start to think beyond? And you tie this with some of the talks coming later. For example, Dr. Griswold, who actually we were just chatting and a lot of things coming along. I think that we can think about not only what we can do to restore function in people that have deficits, but also how we can revolutionize this interaction between man and machine. We've been doing man-machine interaction here at Case for rehab for 30 years, using devices to restore function for people with spinal cord injury. And now we're making a leap, I think, that really changes the true interface between man and machine, which is we're adding sensation to the equation. I'll talk about that, show what we have from proof of concept with people that have lost limbs, and then talk about more of where I think the really interesting things are going from here. So, let's talk about sensation for just a minute, right? So most people are familiar with motor. We've learned how many sensations? 5, right? There's actually 9, but ultimately we think about the typical 5: taste, sound, smell, sight, and touch. And ultimately there are devices already that restore sensations of sound, cochlear prosthetics. There are devices that restore sight, both from people that are profoundly blind, and most of us wear glasses. So there's these things that enhance our capabilities in what we're doing. People are working on smell and taste as well, but the thing is, those 4 senses are pretty much localized. I can put a pair of glasses on, I can put HoloLens on, and we can pretty much connect up with the world, or at least see the world visually through those things. But the largest organ we have in the body, the largest sense organ, is our skin. That's where touch comes from. And while most of these senses are observational, we see the world around us, we hear it, the one that connects us to people, the one that connects us to each other, the one that actually embodies us into a machine is essentially this of touch. Touch is connection. Touch is what brings us together. And it's also the most difficult to change. And when you lose an arm, for example, an amputee, the thing they miss most is not the function of the hand, but in fact the touch. In fact, if you look at it, oh, I missed one here somewhere, it went away. Sorry about that. So in fact, if you look at what's going on, if you come in from the cold weather, and you go ahead and you try to light a match, or you try to undo your jacket. Normally when it's warm like this, it's easy, but if your hand is freezing and you can't feel what's going on, how hard is it to unzip or unbutton a jacket or write anything? Your hands are working perfectly normal. You still have all the exact same motor, the same sensory, or the same motor and the same control, the same mechanics, but you just don't have sensation. The only thing you're missing is sensation, and your hand becomes almost functionless. It becomes very difficult to use. So tactile sensation is absolutely critical to function. And so for people with prostheses, what they've done for a very long time has been working on anthropomorphic hands that look like ours, that function just like ours. But they've been missing the sense of touch, and so those hands, while functionally somewhat beneficial, have been more or less not very useful. So what we've done is said, well, how do we restore sensation? And what we do is we implant electrodes, devices that go onto the peripheral nerve, so the nerve that used to innervate the hand, right? So your hand, the sensors were in the hand, but the wires go all the way back to the brain. So even though I'm missing the piece that picks up the information, I still have a wire that I can tap into. So our question was, if I tap into that wire and I put the right language, the right information onto that wire, does the brain think it's fake, or does it think it's my hand? And what it turns out is if you place these in the right place, like we have here, so this is 3 electrodes on the 3 different nerves that went to the hand, different subject. We actually have 3 people now implanted with electrodes that communicate to these wires. The other thing we did is we said, if I wanted to control that hand, if I recorded, when your normal hand is you have the muscles in the forearm that tell the fingers to contract. Those muscles still exist in a lot of our subjects. So if I were able to take the signal from that muscle, and even though it doesn't go to anything, but use that signal to drive the motors of the hand, can I make the hand also perform just like you or I would? So now we have a complete system, motor and sensory, if this all goes together. So now we have, this is our 3rd subject most recently. Now these have been over 5 years. These people have these devices. This one was in April of this year, but our first subjects were like 5 years ago. So these devices are long-term in people. They don't know they're there if we don't turn them on. So they're stable. These are interfaces that work long-term with people. And so what we asked is, can we control things from the muscles, and can we feel with sensation? And what it turns out is we are able, in fact, to restore, and I'll show videos that talk about this and then where we go. We can, by stimulating, we can restore different places on the hand. And so this is a great thing about science. For you that are thinking about science career, there's 2 great days of my life that I remember from a science perspective. The first day is the first subject, about 5 years ago, it was 4 years ago, came in. We'd put these devices in his arm, and we said, will he even feel anything? We turned the current on, and for the first time he gets this funny looking on, and he goes, Now he's missing a hand. He goes, wow, that's my thumb. That's the tip of my thumb, and that's the first time I felt my thumb since I lost my hand. Now he has a phantom hand. There's a perception of a hand. But when we artificially stimulated it, he said, that's my thumb. That's the first time I felt my thumb since I lost my hand. That was pretty cool. That was one contact. We have 20 different locations around these nerves. We turned on another one. He goes, that's my fingertip. We did this, and he could feel 20 different spots around his hand. Around his entire hand, we could restore sensation to different parts of his hand. Now, at the first time, it felt like a tingle. Like if your hand is waking up, right, you get that sort of tingling sensation. Well, we were stupid. We knew how to put information in, but it was the wrong information. Right? So we were speaking the wrong language to the nerves for a while. And later on, the second big moment was we came there and trying different pulse shapes, different pulse parameters. He's going tingle, tingle, tingle. We changed something, and he goes, that feels just like my pulse. I feel like I have my pulse up against the throat. It doesn't tingle at all, but it's like I'm feeling my pulse here. And then he says, we changed it a little bit again. He goes, I feel like you laid a finger on my hand. So not only do we know where we can stimulate, right? So this is the idea of location. We also know that we can control the quality, what he feels, how it feels to his hand. And then we just recently did a set of studies. We said, well, it's good to know that where I'm touching and kind of what it feels like. But you and I are very exquisite about how we control pressure. I mean, if you want to grab a cherry, for example, or something soft, you want to grab your friend's hand. If you don't know how hard you're squeezing, you don't like that, right? Because you crush their hand. Or if you want to pick up a little cousin or a baby, you got to know how hard you're grabbing. Turns out now, as we can get even better at the language, the intensity of stimulation provides you the same discrimination as the intact hand. So we know the artificial language that the intensity with which I can produce artificial stimulation feels exactly like your intact hand. That's a pretty big deal. That means we can restore the exquisite sensitivity of our hand for functional benefit. Think of all the robotics and things that people are trying to do by artificial intelligence to control this hand in an exquisite way. That you and I have a maybe debatable, intelligent system that actually controls that hand. Now, if I can connect the machine to the person, right? In this case, it's a prosthetic on the arm. But if I can connect the machine to the person, and I can feel how hard I'm grabbing something, everything that you and I can do can be done through that robot. We've also been able to show things about proprioception, position in space, so you can feel where your hand is. We can produce pain, which sounds silly at first, but actually pain's a beneficial thing. So we can produce it in a controlled way. It's for reflexive things. And we can also eliminate this thing called phantom pain. People have pain with the hands missing. They sort of feel it painfully all the time. And to say, one of our subjects said, I felt like my hand was in a vise, and the vise kept turning until my fingers went through the palm of my hand. Imagine that, but you can't rub the hand. You can't do anything to the hand. It just is that pain, and you can't do anything about it. That's the kind of debilitating thing people would have to live with. Since we've given their hand back, that's all gone. For 4 years, this person has not had phantom pain based on the stimulation. So those are the type of things that we can do here. And I'll show, the subject will actually talk about his experience, which is much better than me yammering about it.
So blindfold first, and feel free to adjust it as needed, okay?
A hand without a sense of touch isn't really a hand at all. It's more like a pair of pliers. Watch blindfolded hand amputee Igor Spedek try to pick up some blocks using a prosthetic without a sense of touch. It's not very productive.
That was no sensation.
No sensation.
And so you were just
Going blind.
Just
Literally
blind.
going blind.
Yeah.
Now watch what happens when the sensory perception is turned on. It's like night and day.
But then when I grab it, if I grab it just right, I feel all 3 fingers. If I grab it right, or 2 fingers. Then I know I have it, and then I'll move over and drop it.
Is it your phantom hand that you're feeling it in, or is...
Oh, it don't feel phantom to me when I grab a block. To me,
hand.
it does not. It feels like my hand. It feels like something between my 2 fingers that's vital. Obviously, I know it's an egg.
Step
Can't
by
tell it's
step,
an egg.
researchers are finding ways to let amputees know what they're feeling and how hard they're squeezing. Dustin Tyler is working to make his technology implantable, like a pacemaker. For now, the work is confined to a lab. Igor Spedek looks forward to the day he can take his touchy hand
He has a natural
home.
hand. So the prosthesis is touching, but it's his hand that he feels. And if you notice that one of the things, he was holding an egg. That was a hard-boiled egg without the shell. That's not a shelled egg. That's easy. To go home yourself tonight, take a hard-boiled egg, cut it in half, try to grab it, not pop the yolk out. How sensitive do you have to be to do that? That's what he's doing with the prosthesis, and he can do that blindfolded, just like with sensation level. How does this intensity matter in real life?
Depending on the task, we continuously adjust the amount of pressure we exert. Now, researchers have found a way to convey this precise graded control to a prosthetic hand. And in doing so, they are restoring human connections. Keith Vanderhoevel lost his dominant right hand 11 years ago in a work accident. He's had a prosthetic arm, but he thinks of it as just a tool.
It'd be like you taking one of those grabbers and grab your child's hand. Do you get anything out of it? Do you feel anything? No, you don't.
Now, a new prosthetic system is giving Keith the ability not only to feel his loved one's hands, but also to finely control the pressure he's exerting. That's proven invaluable.
My granddaughters, they've grabbed a hold of my hand. If I'm not watching close enough, I squeeze a little tight and they're like, ow, let go. Because without sensation, can't tell. With sensation on, I grabbed her with both hands and picked her up and could actually feel that I was holding her and not squeezing too tight. And she gave me a big hug. That gets to me.
It's all about creating electrical connections between the prosthetic hand and the human brain.
Our work in this project showed us that we could achieve graded perception of intensity with artificial electrical stimulation.
The electrical stimulation now can come very close to what you have with your normal hand. So we've learned the electrical language. I just want to get in place. So I can talk rather than myself. But the key is, think of this idea of picking up his grandbaby. Whenever he was wearing the prosthesis before, he would always use only the arm that was left. He would not grab her, right? So the point of all these is that we now have a natural hand through the machine, right? So we can also do control. And I'll skip over this. All I want you to point out, ignore the right side, the left, he has these electrodes in his muscles. The right picture is what he's supposed to mimic. And on the left side, he's just controlling that hand naturally. So he's thinking about moving the hand he doesn't even have. Those muscles are contracting, and we're recording that, and he's moving the virtual hand pretty naturally. Just because he thinks about moving the hand that's left, we record that signal, and he can move what's there. So now we have control of a virtual world. We have the feeling as though he's actually in that world. We're developing a system. So within 2 years, this will be completely implanted. Right now, there's wires to the skin. With Medtronic, we're working to put all of this system internal to a device that's like a pacemaker. They'll be connected by Bluetooth to your phone. That means you can connect to this device through your phone. Think about this in terms of the next great talk, or in a couple talks you're going to hear Dr. Griswold talk about HoloLens, which is Bluetooth connected. Think about where this can go. So we're doing it for amputees, right? This is an arm on your body, but that's arbitrary, right? The robot can be anywhere. It could be by the side. It could be in space. Right? So now at this point, if I were in the virtual world or a mixed reality where I can see what's going on, but I can feel it like I'm there. So imagine you're in a VR, a HoloLens, or a other VR setup that is becoming a big deal. You can see and feel, but when you reach out to grab something in the virtual world, it's the robot in the space station. You're not there, but you're there. You can grab what's going on anywhere you want. Deep sea, if the Da Vinci, for example, if a surgeon were to be working with the Da Vinci, he doesn't have to feel the handles. He can actually feel the tumor. He could feel the tissue through this type of interface. So basically, where does it take us, right? We've always think about the man-machine interface. I don't believe in the nihilistic Borg approach, but more like the Iron Man. So the Iron Man is the man in the machine, quite literally. I personally don't want to be in some of those situations that Robert Downey went into. I don't need to be right there with the alien. What I want to do is put myself in the robot that can be there and I can do everything, but I can be off at a safe distance. So we get the idea that we can now connect to the machine. And so things like HoloLens, ocular or retinal contact lenses with pictures in them, right now already, earpieces are small enough and connected by Bluetooth that I can listen to the radio through an earpiece. Okay? So we're already connected. Now, if you take the things like IBM Watson, this is Jarvis, right? This data exists. Machines that can go through large sets of data, but it's projected now to the user through an iPad. But why not connect it directly through the audio or through tactile or whatever it is? So now we have a way of taking anything within 10,000 miles. So if I'm here on the surface of the Earth, anything within the speed of light that can communicate, I can now interact with. So I have a 10,000 mile radius, which I can extend my performance and my capability into the machine from a performance perspective, and a distance into the atmosphere 10,000 miles away. So if you think about the Internet of Things, they're observational right now, but we get to the point where we can put the person into the Internet and the people all together, and essentially turn all of our tools into us, to extend both our capability and our performance. So my time is up. Thank you.